All right, so this next example is actually kind of in the flavor of the 8.4 year term problems, which is kind of combining all of our different special factoring strategies, the ones that involve patterns for us all together. So kind of review your turn. So this problem here, we see first of all, there's 4 terms in it. So remember, that's the factoring by grouping strategy. So I'm going to take these first 2 terms and these second 2 terms and group them together. Out of the first 2, I'm going to group a 3, or take out a 3, and then that's going to leave me with an x squared minus y squared. And then out of the second 2, I'm going to take out a 5, and that's going to leave me with an x minus y. Now, at first glance, you go, well, there's nothing else I can do because those 2 binomials don't have a common factor, but they actually do, because this is our difference at 2 perfect squares pattern. So let's factor that right within this middle of our factoring by grouping. So this now is going to say 3 times x minus y times x plus y, because remember, when we have the difference of 2 perfect squares, that's the conjugates multiplying, and then plus 5, and then times x minus y. Now we have a term here and a term here, and that's where we continue our factoring by grouping strategy. And out of this term and this term, we have a GCF. That GCF is an x minus y. So we'll write that right there. And then here we would cancel that out, right? And we would say, okay, that one goes, and then out of here it's going to go there. So I have 3 times an x plus y here, and then plus a 5 here. And then we want to really multiply this out so that it's simplified, so that it looks like x minus y times 3x plus 3y, and then plus 5. And now we see a binomial times a trinomial. And there we have our final answer. So sometimes you see we can get multiple factoring strategies coming together. So pay attention for those. Now we're going to practice with the your turn here, and we're going to work on multiple factoring strategies. So why don't you guys write down as many as you can see here, shut off the video, try to do them on your own, and then come back and see how you did. So I'm just going to continue on. All right, I see a binomial, I see a difference, and I see squares. So I need a root here and a root here. And the way I factor the difference of 2 perfect squares is the product of their conjugates. So I have a 5x with a 2 and a 5x with a 2, and the only difference between these 2 binomials is that one gets a plus between them and one gets a minus between them. That's what it means to be conjugates. In my next one, again, I look at it, I see a binomial, I see a difference, I see squares. So I have root here is 4x, and then the root here, oh, but you know what? There's a GCF in common too. So I just recognized that. I got a little too carried away, and we don't want to get carried away, because if we get carried away, sometimes we'll forget about it. So I have to take out a GCF, and the GCF here is 4. So I'll take that GCF out, and that's going to leave me with 4x squared, and then minus y to the 4th. And then I'm going to look at it, and I'm going to see that it's a binomial and it's a difference, and those are still 2 perfect squares. So I have a 2x there for a square root and a y squared there for a root. And so now I'm going to finish that factoring out. Don't forget my GCF, 4, and then the root 2x and the root y squared and the root 2x and the root y squared, and then those are conjugates, one with a plus and one with a minus, and that'll finish it out. Now that one, neither of them will go further, always check that, and that'll be the end of it. Now this next one down here, again, I have a GCF, so I'll start with the GCF, and that's going to give me 2x times x squared minus 16. Difference of 2 perfect squares will finish in the